Hello everyone. Today, Adish Manandar, I'm going to talk about text-to-speech synthesis for this technical seminar, and my guide is Mr. Girish sir. We're in batch 2, and so I'm going to start this presentation. So, talking about the contents, I have this given contents over here, which are introduction, motivation, objectives, literature survey, design, experimental study, application, and some conclusion and references, which I took it from IEEE and most of the sites from Google. So coming to introduction, a text-to-speech synthesis is simply a process of converting text to speech. So this process is obtained through a synthesizer, which is a computer-based system that should be able to read any text aloud, whether it was directly introduced in the computer by an operator or scanned or submitted to an optical character recognition system. So this text-to-speech synthesizer was the first device which is considered as speech synthesizer, was a folder by Hammer Donnelly, which was introduced in 1939. So simply a text-to-speech synthesis system converts a written text into computer speeches. Coming on to motivation, what motivated me to do this technical seminar is it can be applicable in various functionalities, not just vocally impaired and common people of the society. You can use it for audiobooks. You can use it to implement in different perspectives of fields and all. What happens is this kinds of. So this happens, and it works in the common people of the society. It reduces eye strains and is user friendly. We can make it a user friendly interface among it, and it acts as a medium between this vocally impaired and common people, and even between common people of the society too. So moving along, my main objective is to provide this system in a non-expensive way for proper medium to capture the it's capable to all the peoples to understand the output obtained from TTS system, which is text-to-speech synthesis system. According to the literature survey, the first device, as I told earlier, was the Voder, which was developed by Hanley. So as given in the front speech, which was given by Hammer Donnelly. So, which came out in 1939. After demonstration of Voder, the world became more interested in speech synthesis. The modern speech synthesis technology involved complicated and sophisticated methods and algorithms which can be found in many modern hardware and software systems. So, according to those IEEE papers, I took out some of the papers and was interested, which was linked to text-to-speech synthesis. So, the first one is text-to-speech synthesis system for Tamil using HMM. What is HMM? HMM is a hidden Markov model which acts as a machine learning algorithm for classification. So this TTS system works in the area of signal processing. So what happens is this machine learning technology, this algorithm learns this Tamil language and converts it into speeches. And that's the basic format of this paper. Going to the next one, which is error detection of grapheme and phonemes conversion into text-to-speech synthesis using speech signals and lexical contents. What happens is while converting text-to-speech, we have a lot of errors of grammatic and phonetic errors, which should be detected properly according to the lexical contents given, according to the lexical components given. So this paper it gives the voice creation involving a phonetic transcription of read speech, which is produced by an automatic grapheme and phonemic conversion of text read. And it also implements a sequence-to-sequence neural network model, which is a machine learning algorithm to obtain a context-dependent grapheme and phonetic conversion. On a French dataset, what happened was it detected about 86.3% of the error made by the commercial systems. So I'm going to the design and method. How text-to-speech synthesizer is formed. as given in the functional diagram over here, which is a general TTS synthesizer. It consists of a text, natural language processing, Prosody Generator, and digital processing. And that digital processing is converted into speech synthesizer, which gives us speech. So moving along with the first part, which is natural language processing. What natural language processing is? It is a field study that focuses on the interaction between human language and computer. It acts as a medium between human language and computer. So it is a simple way for computers to analyze, understand, and derive meaning from human languages in a smart and useful way. Going along in the depth of NLP, which is natural language processing, it consists. It takes in text. After it takes the text, in NLP model, a text analyzer is present, which analyzes text using different processes: pre-processing, morphological analysis, contextual analysis, and many more. So I'm going to talk about those stuff. So text analysis. While analyzing the text, there are these forms, as I've told you about. What happens is a preprocessor model which organizes the input sentence into a manageable list of words. The preprocessor model which organizes the input sentence into a manageable list of words. It just organizes the sentence into a manageable list of words. A morphological analysis model, the task of which is proposes all the possible parts of the speech, characterizes for each word taken individually on the basis of the spelling. So it takes, on the basis of spelling, the speech is characterized. The contextual analysis model considers word into different contexts. The syntactic prosodic parser, which examines a remaining search space, finds the textual structures. So now, after moving to that, the letter to sound module, what it does is it is responsible for automatic determination of phonetic transcription of an incoming text. After that, what happens is a prosody generator works where prosody, which refers to a certain property of speech signals which are related to audible changes in pitch, loudness, and syllable length, which is prosody generator. So what is a prosody generator? The term prosody refers to certain properties of speech signals which are related to audible changes in pitch, loudness, and syllable length. As given in this diagram, which shows that I saw him yesterday. It shows how the inclination of the words and how you pronounce it differs with syllable length, loudness, and pitches. This is done by prosody generator. Moving along, we have DSP. DSP is digital signal processing. As given in the figure, it simply refers to various techniques for improving accuracy and reliability of digital communication. After NLP converts human interaction to computer, this DSP, it improves the accuracy and reliability of digital communication. DSP works by clarifying or standardizing the levels or states of digital signals. So after that, this is simple implementation of how you convert text to speech. Here I'm using a TTS module which consists of TTS system. So what basically I'm doing is, in this program, I'm giving my file, which is the variable or file path. After that, I'm taking the user, getting the username of the current user. After that, what I did was I opened the path and I took some inputs from the user. After taking the input from the user, it saves that input in a speech in this bob.mp3 format, and it saves the mp3 file of user input as speech. After it saves it, it opens this web browser.open my file. It opens the mp3 file. After it opens, this audio is equals to mp3. What happens is this module starts setting a variable along to it, and audio length and all these variables are kept, and the audio is given out or as an input. This time slip, it waits until the audio is finished, and the media player is closed. And until the media player is closed, this program sleeps. And according to it, if you want to continue again, you press Y, or else no. If you press no, you delete the my file, and that's all. This is the simple implication of this system. So going on to the application, There are many applications, as I've already told you in introduction. Some of the application can be used for blind, visually impaired, is the same thing, which is the same thing. And even common peoples for audiobooks, reduce common peoples, where common peoples, they get educational values, or educational values in a sense you can know how to pronounce a word, and which reduces eye strain while studying. While studying, you can use this text-to-speech generator just to listen to it. And communication through voice, it is natural and easier to understand. And after that, after which we get the communication through voice, which improves the word recognition skills and vocabulary along with the pronunciation and all. And it improves the information recall and learning memory enhancements and all. And you can even, if you implement a simple module of converting a different language from different system, you can even add a conversion of different language to minority languages. If you just simply implement that module, a module which converts one language to another in that simple program as I've introduced, you can keep that. Yeah, that's a application. Now moving on to conclusion. As I've talked about NLP and DSP, there are so many advanced areas you can develop it in the quality and naturalness of available voices. This is continued. Important issues need to be further addressed as a purpose. Accordingly, there's not only text-to-speech synthesizer is a simple system, but it can be applied in various fields along with its improvement. In a sense of improvement, what we can say is you can keep a natural voice along with it, and along with the natural voice there should be a proper pronunciation, as I've discussed in the application, and much more. Thank you so much. This references, as I've talked about, these are the references through which I came across to text-to-speech synthesis, and from all these references I took some important notes and points to talk about text-to-speech synthesis. Thank you so much.